Hi everyone, welcome back to part C of the lecture. In this part, we are going to discuss about ERD to database design transformation. Not many slides for this part, so going to cover quickly. Let's share my screen. So ERD to database design. First of all, I click converting any entity relationship to database table is very much principle based, and it's very simple. Sometimes, for example, if there is any entity, strong or weak entity, you have to convert that entity into table, converting all entity into table. And second thing, actually, whatever attributes are listed in the uh, ERD, entity relationship diagram, that has to be a attribute in the table as well, so that becomes column in the table. So in this particular example, you can see there are how many there are 1 2 3 4 5 6 entities are there: customer entity, invoice, order date, shipment, line item, and product. All these entities are going to be converted into a table. So for example, customer table is going to have customer ID, name, address, these three attributes. Customer ID is underlined, as you know. Underlined uh, attribute is called candidate key, a primary key. In this case, actually, customer ID is a primary key. It has got a different significance that will be discussed in the following um, slide. So what is significance? That the underlined customer ID, which I discussed in the last slide, is a candidate key given by the system. It's not a part of the attribute defining customer. This is not a characteristic of a customer. It is basically a key, a primary key, which is given, the candidate key, which is given from the outside as the identifier, and because it becomes a short, numeric, and in the fixed in size, and that's why that is preferred. It's called the surrogate key. It's given from outside. So, and in surrogate key, database management systems applied that number automatically for each row, and it becomes a unique number for each and every row entered into the table. And that's why the correct surrogate key is quite important to work as a identifier and unique identifier and a primary key. Second part, concept is quite important concept. Apart from primary key, for example, in the employee table over here, the employee number is a primary key. There is another key that's called the alternate key, which can also very have a strong potential to be a primary key. For example, email. And email is called alternate key. Email is most of the times email are unique. Not most of the times emails of every individual are unique, and that can also work as primary key. But they are called the alternate key. Primary key is the employee number, which is surrogate key given by the system, because it is a fixed number, salt. It can be generated automatically for each and every row entered entered in the table. So email is another candidate key, and it is written as alternate key in the bracket AK 1.1. I'll explain actually what is the meaning of 1.1 here. 1.1 means this is the first candidate key, alternate key, and it has got only one attribute. So email is the only one attribute to be the part of alternate key one. In the second case, you just see the customer table here. The customer table has got actually customer number as a primary key, which is a surrogate key given from outside by the system, but it has got actually another capability to create another candidate key, or you can say primary key. That's name city combination. Name and city combination that becomes alternate key one, and it's indicated AK 1.1. It means the name is alternate key one, first attribute, and city is alternate key one, so second attribute. So that's why AK 1.1 and AK 1.2 is given here, and this combined combination of the attributes name and city work as a candidate key, uh, uh, and they are called the alternate key. The second alternate key is email. Email AK 2.1. So actually this email is another alternate key 2, and it is one. It has got only one attribute. So that's why it's AK 2.1. There is no other attribute required to make it alternate key. So that's the way alternate keys are defined. In most of times actually when it comes to the default, when it comes to the surrogate key, it's always default values are generated by the database management system, DBMS. It creates actually a new number for each new entry in the table. So for example, in this particular case, there is a table called item, and that item table has got item number as primary key, and that is a surrogate key, this given by the system. And whenever a new item is entered in the table, a new primary number, item number is generated, and that new number is called the default value. New number is getting automatically generated, and automatic number is entered. That is called the default value. How relationship are converted into a table is given in the following slides. So first thing is that actually if there is a one-to-one relationship between the two strong entities, for example, in this particular case, in the left hand side you can see club member and locker. These are the two entities, and they have got actually a very strong relationship. So under that situation, what happened? One entity's primary key become foreign key in the other entity. So, for example, in club member, the member number is primary key, and that primary key is inserted in locker entities table. That's a member number, and that becomes foreign key, and that is also called alternate key 1.1. So locker number is the primary key in the locker table, and the member number is foreign key, and that is also alternate key. Similarly, that can go in the reverse order as well. So that is applied. So locker locker's primary key, locker table's primary key, a locker entity primary key can also become a foreign key in the club member. So either way you can do this transformation. So you can create table with a foreign key in locker table, or you can create table with the foreign key of locker number in the club member table. So the both way you can do one-to-one relationship. But when it comes to one to many relationship, one to n relationship, then um, the, the primary key of the parent entity goes to the child entity. So means parent entity means the entity which has got one, and that becomes that becomes parent entity, which has got one relationship, and which has got many relationship, that becomes child entity. So club member here is one, and club uniform is having many relationship, one to many relationship. So primary key of one relationship means club member goes to foreign key to the club uniform entity, and that's how the conversion happens in this particular following diagram. That actually primary key member number of the club member goes and become foreign key in the club uniform table. um, and that's why this particular conversion happens one to many. So in the many side, uh, the foreign key is inserted. When it comes to many relationship, that becomes little bit complex. uh, it cannot be converted by inserting a foreign key in one of these entities and tables. uh, for translating many to many relationship into the tables, into the database design, you have to create an associative table. The associative table contains primary key of both entities, and that becomes primary key of the associative uh, table, and that also become foreign key from the foreign key for those main entities, basically those main to main relationship. Let me define that with the diagram over here. So suppose here company and part, these are the two entities, and they are associated with each other through many to many relationship. Under that situation, an associative entity company part int is introduced in the right side of the diagram, and the primary key of company, that's company name, and primary key of part number together becomes primary key of company part in int, and they also work as a foreign key for those original, those above tables, company and part. And that's how this transformation happens. That's all for um, lecture 10 of ICT database design and develop, ICT 200 database design and development. Hope you got the concept which I was trying to discuss, and which was covered in lecture 3, lecture 4, and lecture 6. And the part of that is covered over here. Um, and hopefully we can discuss in our lecture class and tutorial in detail. Thanks for attending this class, and see you next time. Bye for now.